Hello, good morning, everyone. We'll just be starting in a few minutes.
Hello.
Hello, good morning, everyone. Shraddha, can we just start or we are waiting for a few minutes?
Shubham, we can start now.
Okay. I hope my screen is visible. Shraddha?
Yes, your screen is
Okay.
visible.
Okay. Good morning, everyone. Today, I'll be presenting the webinar on Netronics schedule. And Netronics schedule is the product by Goem IT. at OMIT. It is a cloud solution and it is a part of the OMIT's cloud app package, which is called as Netronics Manufacturing, and Netronic Schedule is part of that particular cloud apps package. So I am Shubham Yannuvar and I'll be the presenter for you today. I am a SAP functional consultant at Inecom and responsible for the Netronics product. Okay, so today's manufacturing environment requires, fast and intelligent decision making with respect to the production scheduling. And this is the reason where Netronic schedule helps the manufacturers like you guys to move from the process of reactive scheduling to a more proactive decision making in terms of the scheduling of your production orders, right? So what we will discuss and try to achieve today is to understand the value proposition for the product of Netronics schedule, understand the why, how, and what behind the solution. Next, we will try to, at a glance, look at some key benefits of the product. And then I shall, move and proceed into the live demonstration for the product of Netronics schedule. So talking about the product value proposition, Netronics schedule is an advanced visual production scheduling solution, and it is integrated with the SAP Business One platform. The major advantage or the USP for this Netronics schedule is the finite capacity scheduling. So unlike the traditional ERPs, if we consider SAP Business One also, the SAP Business One provides the scheduling capabilities in terms of an infinite schedule. So this is where the Netronics schedule comes in and fills the gap and provides the finite scheduling capability and extend the functionality of SAP Business One in that regard. The system is such that it automatically calculates the schedule of the production orders and displays it to the user in a interactive Gantt chart format. Schedulers can then, with this particular interactive Gantt chart information, make manual adjustments and manual decision makings to adjust any exceptional resource exceptions like the machine breakdowns or the production delays and ensure the on-time deliveries of all of the production orders. So why Netronics schedule? As the production scheduler day in and day out faces some challenges like calculating the accurate and dependable delivery commitments, like the delivery dates for the production orders, managing multiple production order prioritization, like which production order need to be prioritized based on what parameters, handling the machine and the manpower utilization and the limited constraints, and then reacting to any uncertain machine breakdowns and production delays, and to analyze its impact to the overall production schedule. So how this particular Netronic schedule works is that it is seamlessly integrated with the SAP Business One production data based on a plug and play interface. It uses the interactive planning board to visualize your schedule of the production orders and also the resource allocations. So leveraging this particular scheduling engine to automatically calculate a new schedule based on the production orders, priorities, and unexpected incidents, you can make your production scheduling decisions more effectively. So the production schedulers, some of the pain points are the unreliable delivery schedules, meeting up to the delivery requirements. Manufacturers usually face problems with respect to managing multiple variables and dependencies in the production process, managing the production orders prioritization, which production order need to be scheduled first and which is to be scheduled later, and also dealing with the resource utilization, resource allocation with respect to the finite capacity which is available for the machines and the particular manpower. And then quickly, automatically rescheduling is not available in a manual process, which the Netronic schedule solution provides. Some of the benefits are you can calculate accurate and dependable delivery time estimates to your customers. You can ensure reliable delivery time schedules. You can coordinate and optimize the production schedule to ensure all of your machines or all of your resources are being used efficiently. It gives you a clear visibility into the production schedule. You can adjust and resolve any bottlenecks of the machines, whether it is a machine breakdown or a production delay in terms of the delivery dates. So it gives you an optimal use of resources of the machines. And if there are any reduced downtimes, then that too also. It So managing all of this in turn gives you an higher on-time delivery rates, efficient scheduling, leading to more reliable delivery times. So now I'll just start with the live demonstration of the product, and I have some scenarios which we will be discussing today. So the first is the uh, basic scheduling of a production order. So let me just shift my screen into the solution. So this is how the Netronic schedule screen looks like in a Gantt chart format. So what you can see here is the production orders, different production orders that are coming from directly from the SAP Business One database, and it is being scheduled in the Gantt chart format here. On the left, you can see various document numbers which are represented. These document numbers are basically the production order numbers. So, uh, along with the production order numbers, you're also able to see some item numbers or item codes here. On the horizontal axis, you can see the various dates with times, and using this, you can see what particular job is being scheduled when, right? So if I just consider one of my production orders, so this particular production order you can see is for the item code FG0001. This production order contains three operations, that is cutting, grinding, and then an assembly operation. So you can see these three particular operations within that job, how it is being scheduled in the Gantt chart format in the Netronic schedule. So once you just take your mouse on the production order, so you can see a lot of details with respect to that production order. You can see the release date, due dates, the start date and end dates for that production order. And similarly, if you take the mouse to the particular individual operations, then with respect to single operations also, you can see the start dates and the end dates and what are the due dates for that particular job, right? So this is how the production order is getting scheduled from SAP Business One to the Netronics. I will just show you that production order in SAP also here. So that is 352. So this is how that particular planned production order from the SAP Business One, which has three route stages: cutting, finishing, and assembly. This particular production order is getting synced into this particular Netronic solution with one click. You can see here there is one click for the import from Business One. So with this one click, all of the production order data is scheduled in the Gantt chart format. Now with the Netronic schedule, you get the scheduling strategies of two kinds. You get the forward scheduling as well as the backward scheduling. So forward scheduling is what we call the ASAP, or the as soon as possible scheduling strategy, right? So this particular production order, if you see here, has a due date of 22nd of May, right? And since currently the scheduling strategy is ASAP, you can see that particular production order is scheduled as per the forward scheduling starting from right now. And if I update that particular strategy to backward scheduling, that is just in time or JIT, then that particular production order is then scheduled backwards from the 22nd of May due date. So you can see that due date for that production order here, that is the 22nd of May, and it is being scheduled backwards. So as you can see, there is uh, the scheduling and rescheduling of production orders within the solution automatically, right? Then the next is just next is what we'll try to achieve is the finite capacity functionality for this particular Netronics solution. So I will just take you to the SAP and demonstrate two particular production orders in this case. So as the production orders are, production order number is 353. So this is a particular production order for the item SFG 001. And in this, I have taken only one operation in which a particular machine 12 is getting used. You can see the due date for this is the 29th of May, right? And once using only SAP's scheduling, infinite scheduling, I have scheduled this particular production order as a end date backwards. Okay, so this particular machine, machine 12, has currently been configured like 8 hours of production capacity daily. Then I have the consumption planned for this particular production order on machine 12 as 5 hours, right? And similarly, I have posted one more transaction of the production order, which will be utilizing the same machine 12 for 5 hours of uh, consumption, and the due date for the production order is the 29th of May. So both of these production orders have been scheduled backwards. That is the scheduling is happening from the end date backwards with respect to the due date. So what SAP does in the infinite capacity planning is, I will just show that to you. So I've selected the machine 12 and I'll get the refresh. So if I just have a look at the date of 29th of May, you can see the available capacity SAP has overloaded. So it is showing me -2 and the committed capacity is showing as 10 hours. So SAP Business One, while doing the scheduling, considers the infinite capacity for a resource and it overloads the particular resource. In this case, the machine 12. If I just post similar kind of transactions for another machine, considering machine 11, which has again the due date of 29th of May with 5 hours of consumption in production order 355, and again the 5 hours of planned consumption in the production order 356. And if we just see these production orders in the schedule, So you can see here the Netronic schedule solution will never do an overloading of your particular machines as it is considering the finite capacity of the resource. You can see here this particular operation or the job is scheduled uh, on the 28th from 11 a.m. and then the production order 356 is being scheduled on 27th on 2 p.m. after the production order of the 355. So this is how the finite scheduling capacity is available with the Netronics schedule solution. So after this, I will just take you to the next scenario which we have here. So finite scheduling capacity parameters. So this finite scheduling which the electronic solution is doing, it is considering finite capacity of the machine or the resource. And then it is also considering the priority which has been determined for the particular production orders. So the solution automatically prioritizes the production order with the due date which is earlier, and the due date which is later is given the uh, least priority. And the finite capacity scheduling also considers any calendar exceptions for the machines with examples like the machine breakdown. And if you define any such calendar exceptions, it will automatically do automatic rescheduling of all of your production orders. If in case there are any production delays, that particular thing will be demonstrated as red in the solution, and then the decision making becomes easier with respect to that particular production order. So let me just show you one example for this. So considering the production order 352, how the particular capacity is defined for a machine in this solution, I will just show you that. I will go into the manage resources and I will just select one of my machine, and here in the standard calendar option, there is a facility to define the capacity. So currently, I have considered a general shift like 8 to 4 o'clock shift, which is 8 hours, right? And if you want to define a specialized shift, like it will be the machine working time will be 8 to 12 noon, and then 2 p.m. to maybe 6 p.m. and let me click on OK. So automatically that particular consideration will be taken. So here you can see, let me just expand to the mid-well. You can see from 12 to 2 here for the machine 1, which is this particular bar, right? You can see that it is being shown as a non-productive time, and that particular production order is now getting started at 2 p.m. So this is how you are defining the machine capacities within the solution. If there is some kind of an exception, like the machine one has a particular breakdown, for example, then we can accommodate that also within the solution. Again, I will go to the calendar exceptions here. In the calendar exceptions, I will have to select the machine 1 year, and for what date, that is the 20th, I will define. So the work time will be from 8 to 12 only, because after the suppose we are defining like after 2 p.m. there is some machine breakdown. So the work time was only 8 to 12 p.m. and that we can categorize as the machine breakdown. And let me just add this to the exception and click OK. So once I do that, you can see it has automatically done a rescheduling for the production order, and it is showing me that particular machine breakdown here, and it has rescheduled that particular task of the assembly operation, which is on machine 1 to the May 21st. So any calendar exceptions can be managed and automatically reschedule can be run for the production orders in the Netronic schedule. Suppose I just define one another calendar exception for this particular grinding machine here on the May of 20th. May 20th, and I will give it as some maintenance. So there will be no work time defined, and add this to the calendar exceptions and click on OK. So again, there is an automatic rescheduling of the production orders, and that particular production order is scheduled on the 21st. And once that grinding operation is rescheduled, automatically the rescheduling of the assembly operation, which is the next operation in that production order, that also has been rescheduled. So automatically any kind of calendar exceptions also is being taken care of by the solution here, right? And as I said, any kind of production delays, as you can see here, is demonstrated in the red color. So let me just check one for that. So suppose this particular production order, you can see here, is it is being shown in red because for that particular production order, you can see the due date as the 21st of May, and it is showing that this particular production order uh, task end date, if you can see here, task end date is the it is getting pushed to the 21st, so it is not meeting the delivery deadline. So in this case also we can take some manual decisions as per to cater to the due dates. So again, I will go to the calendar exception and I will select that particular machine, that is 23, machine 23 on the 20th. Suppose it will burn for extra time. And click on OK. So doing that, as you can see, automatic reschedule is done for that particular production order. And you can see that it is not red colored anymore, and the particular task end date is been completed by the 20th of May at 4:25 p.m. So all of these finite capacity planning parameters is being taken care of within the solution. So I'll just move into the next scenario. So this is the next scenario which we have, and this is a quite powerful functionality, and this I will show it to you now. So suppose you have similar machines. For this example, I have taken an example of a turning operation. You can see here, and it suppose there are three identical machines which can do that particular operation, right? And you have a production order which has the turning operation. So during the scheduling, what Netronics can do for you, it is that it can automatically allocate the production order to the next available machine. So for that, what we require to do is that we require to put a dummy machine, that is TM underscore machine, in the production order, and it will do an automatic scheduling as to which particular machine from machine 1, 2, or 3 can be used, right? So I will just show you one of that example here. So that is these examples for FG002 and FG006. So these two production orders, as you can see, I had used the uh, dummy machine like TM underscore machine, but the solution has intelligently provided me what particular machine. As you can see here, the TM machine 2 is being used for this production order number 350, and TM machine 3 is being used for the production order 351. So automatically that particular machine can get assigned to a particular production order. So let's just see that particular production order. So this production order has a due date of the 27th of May. Now suppose if I go ahead and add one more production order for the due date of 27, we'll take the similar example. You can see here in the production, I am taking a dummy or the common resource group machine here, and I will just put some consumption. Like plant consumption will be 4 hours, and let me just add this. Once I add this and click on the import, so that particular production order, you can see here that particular production order is scheduled here. And if I just update the scheduling strategy to just in time, so automatically you can see here that the machine 1 is being allocated to this particular production order. So to the production order 350, machine 2 is allocated. Production order 351, machine 3 is allocated, and production order 361, the machine 1 is allocated. So you can do an grouping for your similar or identical machines, and then based on the available machine, the solution will automatically allocate that particular machine to the operation. You can see here in the resource group, here is the group of resource group and the different machines linked here. Okay, and now in this case, suppose uh, the output of the machines is different. So let me just define production output for machine 2 as 2 and production output for machine 3 as 4. So this is actually the productivity, right? And I will just click on OK. So what this does is you had given the resource consumption as the 4 hours, but in the schedule, considering the productivity also, it has rescheduled, and now that the task lead time is considered 2 hours because I had defined productivity as 2 for this particular machine. So that is the task will start at 3 p.m. and it will end at 5 p.m. So the machine output in the solution which we are calling as productivity is also considered when doing the scheduling of this particular production order. So next I will move into the scenario 4. So in a production order, instead of going one by one completing the production order, if there are examples of parallel operations within the routing, so that too can be managed within the solution. So let me just show that example to you. So this particular production order number 359. So now this production order has multiple operations like the low voltage winding, high voltage winding build for, and as you can see, these are scheduled one after the other. Suppose in the actual case, in the production order, uh, you want to have some parallel operations. So suppose build core assembly runs parallelly, or the manufacturing starts parallelly with the low voltage winding. So I can just go into the task and remove the predecessor task and just click on OK. So once I do that, automatically you can see that the build core assembly and the low voltage winding, that is the first and the third operations, are now scheduled as parallel, and this in turn leads to the reduced lead time for the entire production order. So this is one of the functionality of the Netronic schedule. The next is in case of continuous production. Suppose there is a bulk production order and you need not wait for, and it has multiple operations. So there is a functionality in the solution like, just a minute. Which is called a send ahead quantity. So let me just go into the edit of production orders. For each and every operation, there is a functionality called a send ahead quantity. So this particular production order was planned for 10 quantities. Just show that production order to you. So this is a production order for FG001, which is planned for 10 quantities, and the cutting, finishing, and assembly operation require 10 hours each of the consumption. So this particular production order, if you see currently, I have defined that send ahead quantity as 10 numbers. So the next operation, that is the grinding operation, is getting started once the entire cutting operation for the entire batch, that is 10 quantity, is completed. So instead of that, there is an option to define send ahead quantities for individual tasks. So suppose I define this as 1 and click on OK, then again click on OK. So there is an automatic rescheduling, and the particular grinding operation gets started after one quantity is completed manufacturing on the cutting machine. So you can see here the task start date for the cutting machine of cutting operation is 1 p.m. and then the task start time for the grinding machine grinding operation is 2 p.m. So you can also define the send ahead quantities for individual tasks, and I will just define this for the remaining task. Once this is done, so you can see there is a drastic reduction of the overall lead time for that particular production order, right? So this is all the scenarios which we have for today. So I will like to open this uh, session for questions if you have some questions for us. Yes,
We are having a one question that
yes,
your
10.
routing is connected to production order or routing can be done on engineering work.
Yeah, correct. So the routing is basically done on the bill of material. I'll just show that particular example. So this is the bill of material, and on that bill of material you do the routing.
So
And
again,
in
I'm
each
question.
hmm,
I'm telling that it's a manufacturing bill of material or engineering bill of material, because engineering bill of material cannot be take the routings. as per my understanding, because my system SAP B1 is only having an engineering BOM. Once I'll be going to take the MRP, the production order will be generated. Otherwise, engineering BOM, I cannot do the routing. And you are telling that the engineering BOM, you should have to do the routing on engineering BOM. Am I right?
Yeah. So what this solution has is that it is considering the production orders. And in that production orders, what you are calling an engineering BOM, it is considering that particular routing into the schedule.
No, but in the engineering BOM, because for let us suppose we are doing, one production actually for X machine,
Okay.
and after 3 days there is change in the BOM,
Okay.
and we have only one BOM actually. So if we change the BOM, in that case, what is going to consider, the 3 days previous BOM or the current BOM?
No, no, no. It is always considering the production order. Whatever the plan or the BOM you have on the production order, that is getting considered. So if you are doing any changes, like you said, after 3 days there are some changes and you want to do those. So you will have to do those changes on the production order. As you can see here, if you want that, suppose in this particular production order, instead of machine 1, there is a machine 3.